14th, correct?
Yes.
Okay, so we've talked about addition and subtraction with radicals, and now we're gonna talk about multiplication and division. Multiplication, just like whenever we did the addition and subtraction, it was how we would add or subtract like terms, how we would combine like terms, but now we're talking about like radicals, and now we're going to do the same thing, just with multiplication. So, this is 6.3 continued. Haven, did you start the video? Okay. The same rules apply once again as whenever we have just regular terms. So if I have something like the square root of 5 times the square root of 15. Remember, whenever you add or subtract them, you cannot just combine them underneath, but whenever you are multiplying or dividing, you can just combine underneath. So if there are two radicals being multiplied, that means that I can just combine them and multiply underneath. So what does that end up being? Square root of 75. Now this feels a little bit backwards, but if you put this answer in, it's going to tell you that your answer is not in its simplest form. Because what did you just do? You just like combined two things and made them one. Well, now we're going to separate them again, because we're going to look for, is there a largest perfect square that goes into 75? Is there a perfect square that goes into 75? That divide? Yes, 25. 25 is a perfect square and it divides into 75. So that means that I can separate 75 as 25 times 3. A reminder, you need to ask yourself that every time. Now if I started here and I said, well, is there a perfect square that goes into 5? No. Is there a perfect square that goes into 15? No. So you can't simplify those any further, like stand alone, but once you combine them, you can. Okay, again, since it's being multiplied, I can separate it as the square root of 25, the square root of 3. What is the square root of 25? 5. Square root of 3. A little bit tougher because it's a binomial times a binomial. What would I do here? You would either FOIL or distribute. Yes, FOIL or distribute. I know that I remember whenever we did this, it was about half and half in the class. Some of you like to FOIL, some of you like to distribute. I'm going to go ahead and FOIL. So if you are like a distribute person, just go ahead and do that. But I'm going to FOIL this out, meaning I'm going to multiply the first terms together. So 3 square root of 7 times the square root of 7. Outer terms together, so plus 3 times 3 square root of 7. Inner terms together, so negative 2 times the square root of 7. And the last terms together, negative 2 times 3. On this first term, I have the square root of 7, square root of 7. I can combine those because they're both underneath a radical. I can't put the 3, like I can't do 3 times 7. That would be 21, but I can't do that because the 3 is outside the radical, the 7 is underneath the radical, okay? So, 3 times the square root of 7 times 7, plus we can go ahead and do the 3 times 3 because both of those are outside of the radical, which would be 9 square root of 7. Minus 2 square root of 7 minus 6. What is 7 times 7? 49. So 3 times the square root of 49 plus We can actually combine these two. Why can I combine those two things?
Because they have the same square root.
Yep, they have the exact same radical and the exact same radicand, meaning they both are square roots and both square roots of 7. So how do I combine them? I just combine the coefficients. So 9 minus 2. What is 9 minus 2?
7.
7. Now what's underneath the radical just stays the same, and then I have minus 6. 3 times the square root of 49. Can you actually evaluate what the square root of 49 is? Seven. Yeah, the square root of 49 is 7. So I can evaluate that and just take it out of the radical. So 3 times 7 plus 7, square root of 7 minus 6. So 21 plus 7, and I'm showing every step. Now if you wanted to jump from, here to 21 minus 6, you could. I'm just making sure everybody knows where all my numbers are coming from. Questions there? Again, that's just our foiling or our distributing, whichever one you typically use. What if I have something like, well, actually, I want you guys to try one of those too, because some of you don't foil, some of you distribute, and I want to make sure that how you do it works as well. You guys try that one. Okay, so it looks like a few of you are done, so I'm gonna go ahead and get started. I can distribute, or FOIL, whichever one. So I have the square root of 6 times the square root of 6 plus, or minus the square root of 2 times the square root of 6 plus the square root of 2 times the square root of 6 minus the square root of 2 square root of 2. Now you don't really have to do much here. Like if you went ahead and made this the square root of 12, that's fine. But notice this is negative square root of 2 square root of 6 and then a positive square root of 2 square root of 6. Negative and a positive of the exact same thing. What happens? They just cancel. It's like a negative 5 and a positive 5. They would cancel. I end up with the square root of 36 minus the square root of 4 which is just 6 minus 2, which is just 4. Questions? How do we do?
So that's one thing I don't think I realized. The negative, so whenever you do negative square root of 2 over there,
Mm-hmm.
Times square root of 2, the negative stays with it.
Yes.
Okay, I wasn't
Mhm.
sure.
Yep. Okay, this one's similar. We have the square root of 2x, square root of 2x plus 5 squared. Square root of 2x plus 5 squared. What does this mean? Again, I want to remind you that whenever you have a binomial squared, you cannot distribute the power. You cannot distribute that 2 unless it is multiplication or division. It doesn't work that way. What do you need to do whenever it's addition or subtraction? Yep. You just write it out and you FOIL it or distribute. Whichever one, once again. You make sure you copy, paste, FOIL, and then same as or similar to what we just did. So FOIL it out. So we have the square root of 2x times the square root of 2x plus 5 square root of 2x plus 5 square root of 2x plus 25. Square root of 2x times the square root of 2x, that's just, I don't know if you guys have noticed yet, but they just keep canceling. Does everyone see that? Like whenever we did the square root of 7 times square root of 7, it just ended up being 7. Square root of 6 times square root of 6 ends up being 6. Square root of 2, square root of 2 ends up being 2. You could just skip that part of trying to evaluate it. Plus, these are like radicals, so 10 square root of 2x plus 25. Can I combine anything else? No. I cannot combine the 2x and the 2x because one is underneath a radical, the other one is not. I can't combine the 2x and the 25 because one of them has an x, the other one doesn't. So this is as much as I can combine it. Questions here? Okay, now we will get into rationalizing the denominator. Rationalizing denominators of rational expressions. So an expression with a radical in the denominator. May not be the most usable form in algebra. So what that means is if I have a fraction and I see that I'm dividing by a radical expression, what we want to do typically is get rid of that radical, and that's what rationalizing the denominator means. So to make calculations easier, we may want to rationalize the denominator. What that means is we want to find an equivalent fraction in which the denominator is not a radical. Okay, so what that entails, what that's gonna entail, is us just multiplying the top and the bottom by whatever the radical is. So if we go back, I'll wait till you guys finish writing that before I go back, but you know, I just said if we have the square root of 2x times the square root of 2x, what does that end up being? 2x. Square root of x times square root of x ends up being x. Square root of 6 times square root of 6 ends up being 6. Square root of 2 times square root of 2 just ends up being 2. So you see a pattern there. If we multiply the radical by itself, it is getting rid of the radical. If we multiply it exactly by itself, it is getting rid of the radical. We're going to use that knowledge that we have there. And then also the knowledge that if I multiply anything by 1, I don't change the value of a problem at all, right? So if I take a fraction and I want to, like, let's go back to chapter 1, whenever we were adding and subtracting fractions. What did we do there? We multiplied the top and bottom of fractions so that we could get common denominators so that we could add or subtract, right? And that was totally fine. Why? Because we're essentially just multiplying them by 1 or different iterations of 1. The exact same thing can happen here. So let us look at some examples. I have the square root of 5 over 12x. Just a quick reminder that if I have division underneath a radical, I can separate it. Just like if I have multiplication underneath a radical, I can separate them. So this can be the square root of 5 over the square root of 12x. All right. We're wanting to rationalize the denominator. That means get rid of the fact that there's a radical in the denominator. What is the radical? So which radical do I have a problem with? The 5 or the 12x?
The 12x.
The 12x, because that's what's in the denominator. Now, it doesn't mean that I want to get rid of 12x. I want to get rid of the fact that it's taking the square root of 12x. So how did I get rid of the radical before? You know, again, if I go back to multiplication, we kept noticing if I multiply the same thing together, the radical goes away. So if I multiply this by the square root of 12x, we know that that's just going to end up being 12x. The radical is going to go away. I can't change the value of my problem, so I can't just multiply it by the bottom because it's going to change the value of it. What do I also need to do? Multiply the top as well. Because what is 12x over 12x?
X.
1. Anything over itself is 1. 5 over 5 is 1. 8 over 8 is 1. Negative 3 over negative 3 is 1. And whenever you multiply something by 1, have you changed the value of it at all? No. It's the same. So here we end up with the square root of 5 times the square root of 12x. And then here we end up with just 12x. Now, if you're still confused, if you're confused as to why that just ends up being 12x, this is the problems that we were doing before. You know, I was showing you and then I stopped showing you because this ends up being the square root of 12x times 12x, which is just the square root of 144 x squared. Separate square root of 144, square root of x squared, and you just end up with 12x. And that will happen every time. If you're multiplying a radical by itself, the radical is just going to go away and you're just going to have the radicand. So there's no need to do all that every Okay, so since I'm multiplying on top here, I can just go a little bit further. The square root of 5 times 12, what is that?
60.
So we have the square root of 60x. And then I ask myself, what is the largest perfect square that goes into 60? How do you find that out? You use your calculator. Take 60, divide it by, let's see, what's the smallest one underneath the 60? 49. 60 divided by 49 doesn't work. 60 divided by 36 doesn't work. 60 divided by 25 doesn't work. 60 divided by 16 doesn't work. 60 divided by 9 doesn't work. 60 divided by 4. So this ends up being square root of 4 times 15x over 12x. Can these x's cancel? No. One is underneath the radical, the other one is not. Okay? One is underneath, the other one is not. They have to be like in the same family there. Square root of 4, square root of 15x over 12x. End up with 2, square root of 15x over 12x. Now, the 2 and the 12 are outside of the radical, so they can simplify. What goes into both 2 and 12? 2. So this would just end up being 1. This would end up being 6. So the square root of 15x over 6x. Again, I can't say, well, what does 15 and 6 have in common, or the x's can't cancel, because one is underneath a radical, the other one is not. Square root of 14 over the square root of 6. I'm wanting to rationalize the denominator. What rationalizing the denominator means is I want to get rid of the radical, okay? So which radical do I have a problem with, the 14 or the 6? The 6, because that's what's in the denominator. So how do I get the 6 to go away? Multiply it by itself. Remember, you can't just multiply the bottom by it, you also need to multiply the top. Okay, multiply both the bottom and the top so that it can cancel, and you just end up with 6 on bottom. And then you have the square root of 14 times 6. Square root of, I don't have my calculator up here, what's 14 times 6?
84.
84. And then to yourself, what is the largest perfect square that goes into 84? So you could start with, again, 49. You could do, see, 84 divided by 49 doesn't work. 84 divided by 36 doesn't work. 84 divided by 25 doesn't work. What is it? 4? What can simplify here? The 2 and the 6, because both of those are outside of the radical. So we're looking at the 2 and the 6 here. What goes into both 2 and 6? 2. So 2 goes into 2 once, 2 goes into 6 3 times. So we end up with the square root of 21 over 3. Again, please don't get carried away, because what do we want to do here? We know that 3 goes into 21, right? Like mentally, we're like, oh, it's 7. But why can't we do that? Yes, this one is underneath the radical, this one is not. If they were both underneath, works perfect. We could do that. One is outside, one is outside, one is inside. So do not, be very careful of that, because your brain wants to do that. Okay? So be careful of that on your exam. Okay, I'm gonna give you guys one to try. How long has that been recording, Hayden?
26 minutes.
Okay. I wanna try not to get it over 30, because for some reason, if it's over 30, like, if it's under 30, it can upload within an hour. If it's over 30, it takes literally all day. I don't know, I guess it, like, the file size is just drastically different.
So when it hits 30, you want me to stop and just start a new
Yeah,
one?
yeah, we'll do that. We should be, because this is our last example, so we should be good. Okay. So what do you wanna multiply by?
20.
Yep.
The square root.
Square root of 21 on both top and bottom. Okay, what is the square root of 12 times 21?
252.
252 over, and this just ends up being what? 21. Okay, what is the largest perfect square that goes into 252, or is 252 a perfect square?
36.
36. So the square root of 36 times what?
7.
Over 21. So square root of 36, square root of 7 over 21. We end up with 6 square root of 7 over 21. Now what can I simplify?
The 6 and the 21.
The 6 and the 21. What goes into both 6 and 21?
3.
3. So we have 2 and 7. This is again one of those ones where I want you to be careful, because what does your brain want to do? It wants to cancel the 7s, right? But one is underneath the radical, one is not. So they cannot cancel. Alright? Questions over this. Okay, so that's all we have is we did our division by radicals, and we have our multiplication by radicals. This is the end, so we don't have any more. Meaning on Monday, whenever you come back, you will, we'll do a review. You know, I'll make sure you bring your iPads so that you can start that, you can ask your questions, all of that. On that Wednesday, you will have an exam, okay, whenever we come back. That Wednesday, remember, that is exam day. A quick overview, you can stop the video now, Hagen.